That brings us to Clovers and cadCAD. cadCAD stands for Complex Adaptive Dynamics, Computer-Aided Design. It's being built by Block Science. So they have this sort of lather, rinse, repeat idea in which you would, say, model your configurations of your token model, integrate real-world data, and then update that system in order to let it run with computation and projections. Once it's sort of out in the wild, you get some insights. Those will inform decisions in your design in which you will modify your system. Then you abstract those into a model. You can run simulations again, which might make you alter it again. Then it goes into the wild, so that you should continue doing this sort of feedback loop of modeling, updating, running your system over and over again. So we've begun doing that with Clovers, mostly on the reward functions. That's where I found the most value out of that process in the last month or so. But cadCAD itself is a finite state machine. It'll, has a state like on and some actions like flip switch, which will result in some new state like off, and then you can do some new action. So it's all a finite state machine is. It's just state, action, state, action. You begin with an initial state. In our situation, it is the symmetries that exist. So I was able to take real-world data from the testnet version of Clovers, which is starting to sort of reveal the numbers of types of symmetry. There's way more diagonal symmetry than perpendicular, and there's very, very little rotational symmetry. So these numbers informed the starting point for symmetries. You have the bonding curve data, what's the current total supply, what's the balance, what's the connector weight, the reserve ratio, all those sorts of initializations. And then we're using a network graph to model every specific Clover and every specific user who might be a player, a miner, or the bank, the contract who would pay out the money. Our network graph. So within each player, they each have a proposed hash rate. This is based on the Clover PEGG hash rate. So this is assuming a player is using the browser. They have a percentage active and a percentage online. So even if they're online, they might not be actively mining. And they have a propensity to buy. I'll talk more about like what goes into the logic we've applied to trying to assume when somebody would or would not buy something. A miner similarly has a hash rate, a percentage where they're active and online. Those are very high numbers for a miner, where you could imagine somebody could just set a computer to run in the background. Propensity to buy is 0. They will never buy a Clover. They only want to cash out. But they do have a cash out threshold. So how often should they exchange their Clover coins for Ether? If they were to do it every single time they got it, they'd be paying a lot in gas fees. So we set it at 0.1 ETH. Every time they have a profit of about $30, they cash out. You have Clovers, which themselves have their own symmetries. We record what the reward was for them. They also have a current price, which will determine whether or not they're on the market. If the price is 0, we assume it's not for sale. If the price is anything but 0, it's for sale. We also know who the owner is. And we have the bank, who's basically just burning all of their profits. Inside of cadCAD, you have something called policies, and you have state update functions. Policies basically inform your decision to update the state. They're supposed to be sort of the thinking process and the doing. If you're familiar with like React or Redux or Vue or Vuex, they're sort of actions and mutations. So the policy is where the decisions take place. They're eventually going to pass the instructions to the update functions, and they all run in parallel. So you might have 3 policy functions. They're all running at the same time, so they don't really inform each other. Same goes for state update functions. State update functions run in parallel as well. They actually modify the state, but they modify it one key at a time. So this might be a little counterintuitive that you'd have all these state update functions running in parallel, because often a state update function should be informed by whatever took place right before it. So if a bunch of new users joined, probably the state update function would be different depending on that big group or loss of users, which is why you make groups of them. So you have groups of policies and groups of state update functions, and those run in sequential process. To give you a little model of it, you can look at it here. So you have this initial state, moves over to the policies group A. Policies group A runs in parallel. So there might be 3 or 4 functions running sort of ideas about what's happening. Those all run in parallel. They hand off their findings to the state update group. All of the state update functions inside of that group are run in parallel, but they all take the same information from the policies, and they result in a new state. So if you had some state update that should be informed by the previous one, you would put it into a different group. That's what group B is like. So you can imagine it goes through group A, then it goes through group B, group C. At the very end, it says what is the current time step. If you're running a simulation that has 100 time steps, 1,000 time steps, and you haven't run all of them, sends you back to the beginning and runs it again. If you're at the very end, obviously you end and you have your final state. So our policies. We have a participant policy. This is about, are there more players? Are there more miners? We have a sort of very slow increasing number of those. Try to be conservative about those. We have the miners handling clovers policy. So based on the hash rate of all the miners, the percent of them online, and the number of miners in existence, plus like the time step, which we've been using as a 1 hour time step, in that period, what is it likely that they are going to find how many symmetrical clovers? This number is based off of some very crude number crunching that I found sort of 1 out of every 10,000 randomly played games ends up being symmetrical. Similar policies apply to players. What is their hash rate? What is their percentage online? What is the current time step? And then there's market intentions. This is about how many clovers should I buy as a user? How many should I sell? And this has to do with something we've been calling objective versus subjective value. And I'll get into that more in a second. Briefly, again, there's these state update functions which are handed off this information from the policies. With the participant, they actually just enact those. OK, add this many people, remove this many people. The miners, they check to make sure that the reward is actually larger than the gas cost. Otherwise, they won't go through with it. They will execute those rewards. And sometimes they will cash out, which means they will actually sell their tokens on the bonding curve. Player actions. Again, this objective to subjective that I'm going to talk about in a second. But they also, similar to miners, will execute rewards. Some of them just want to cash out money. Some of them want to keep the clovers, so they'll execute those. And sometimes they need to buy new clover coins in order to facilitate this process. Market actions will execute this market activity that we discussed in the last policy. And for the third time in the last 30 seconds, objective versus subjective. So maybe I should get to that. No, I won't. First, you should be aware of the worst case scenario. So my goal in using this was basically to test, OK, we're going to use the rest of the funds from the ECF to jumpstart this bonding curve. Basically, we're going to put $10,000 into the curve and tell people that they can mine for rewards. How long do we have if the absolute worst case scenario happens? Like if it's just miners, nobody cares about this game. It's just people who see they can make like a 30-cent profit every like 5 minutes. Like, how long do we have? So we modeled the worst case scenario, which was miners only. We gave them a huge hash rate. We put in the $10,000, which is about 32 Ether, and gave 10 miners with hash rates that are 10 times the pig hash rate. 10 days it took them under our best scenario. So this is the first time that I started that cycle system where tweaked a parameter, ran the simulation, tweaked the parameter, ran the simulation. And we found a reward multiplier. And I'll show you the reward calculation in a second that gave us sort of like the optimum return of the number of clovers we were able to produce from just purely selfish miners. And that was 18,518. Now, again, all of these simulations, any simulation anyone ever shows, you take with a huge grain of salt. I'm just trying to sort of do as much due diligence as is possible without actually modeling every moving atom in the universe. But if this is a worst case scenario, this is a huge win. The idea that I could jumpstart some group to mine 18,000 of these clovers. Like if I walk myself back to my original reason, which is sort of trying to produce these things to make artworks, this is a huge, huge win. So if I can start at this baseline and tweak the system to move up from there, we've already sort of won. So starting from the bottom, we took the state that resulted from this 10 days of just miners as the starting point. We assumed that there was a nuclear fallout, and this is actually where we begin to have the system. And then we allow normal users. Say we've already had the worst case scenario, but now we actually have normal people who might play with this. What happens then? Running the simulation with the sort of very crude, admittedly, logic of who would play with this, why would they play with this, when would they interact with it, et cetera, we saw that people continued to produce clovers. Basically, the price jump that occurs every time somebody legitimately interacts with the system was enough to offset the purely negative miner impact. And it became sort of this seesaw you can see here. So these are the reward you get per symmetry type in Ether, and there's this baseline, which is the cost to actually mine it. And so this is where you see the prices are constantly jumping through. So as long as one person buys one legitimately, the price per token will jump high enough to make it profitable for other miners or other players in general to participate, which might drive it back down until somebody else participates legitimately. So you have this sort of like zigzag thing going through here, but what you don't see is that it actually starts going back up again. So this is the coin price and the market cap. It's kind of hard to read. After 30 days of starting at the bottom, from our sort of rate of players growth, which is maybe already grossly overestimated, it went from 10 players to 400, went from 1 miner to 100 miners. So even if the 400 players is maybe an overestimate, probably 100 miners in that same capacity is as well. And it produced another 94,000 clovers over the next 30 days. An additional 75,000 clovers. So again, if I can start from the absolute worst case scenario and create a system in which people still produce clovers, I would count this as a win. So again, this search reward I talked about earlier, I would love for anyone to check this out probably in more detail. Maybe in an open floor is not the best place to sort of dissect code, but just to give you a bit of an idea of how the reward systems work. Basically, the more of one symmetry type you find, the less valuable it gets. So you can see that by, say, this is a symmetry type, it's the denominator of all the symmetries. So as the number of all symmetries go up, and as this one increases at a similar rate, those values will push each other down so that the reward is lower and lower for this guy. Whereas the rotational symmetries, which become very rare, you have a small number in the denominator and an increasing number in the numerator, the payout will be larger. These are still quite small numbers, and so they get multiplied by a pay multiplier. And this is where most of the editing took place in the simulation model. How do we change this pay multiplier so that it's not paying you too much and you just drain the collateral pool too quickly, and it's not paying you so little that you end up not making enough to pay the gas, and a lot of money just basically gets locked up in there. So we wanted to make it like useful, and this was the sort of way we were able to combine and find a number that basically allowed those miners to completely drain the collateral pool, because that was basically the most effective use of that collateral. They were able to produce the most number of clovers in the most adverse situation. So this is the objective versus subjective thing I want to talk about. And I think this is really interesting for a lot of other situations as well. When you're dealing with agent-based models, like how do you evaluate when somebody would want to buy something versus when they would not want to buy something? Obviously, everyone has their own sort of personal evaluations for what they want to do something and when they don't want to do something. So how do you account for that in a simulation model? This is probably the hardest thing to do. And so we tried to come up with an objective value for each clover. And this is a combination of the reward from the symmetry, which is a very hard objective value. This is a cash in hand value, the reward. We multiplied it by some freshness amount, which is sort of believing that newer clovers are somehow more interesting. They get more attention. They have less time that other people have seen them. So chances are there's less chance that somebody who would have wanted it already took it. And the je ne sais quoi sort of like pretty factor, which is the sort of like, I don't know, you have strange tastes, and it just so happened that that had your strange taste. So there's a sort of element of that as well. And that gives you sort of a concrete number. But then this concrete number isn't very helpful unless you have standard deviation. So with that concrete number as a starting point, there's a standard deviation that can go wildly below it or wildly above it. We had to use a very large standard deviation because we believe there's not a very good set for evaluating the value of these things. So every human is going to have their own opinion about all of these things are worthless or this thing is so valuable. And so as long as we can have a very large standard deviation, we can use this objective value as a sort of starting point and allow people to make their own decisions around those. Something that we thought about is maybe over time a sort of common language might emerge over any sort of evaluation of any object that you sort of work towards commonality and understanding each other, and maybe you are able to sort of start having a blue book where you're like, oh yeah, we all know that this is valuable because it has this history, it has this context, it went to market last time or something like that. And so the standard deviation might decrease over time. But obviously in a very early stage thing like this, we wanted to use a very large one. We also seeded the randomness of the standard deviation by the user ID and the clover ID, so that if you encounter a clover once and you decide not to buy it, you might encounter it a second time, and your evaluation of it compared to the other one will be consistent, even if the other one's value has increased or decreased, which was, I think, really exciting sort of way to think about value evaluation in any system. At the bottom here, you can see sort of examples of something that would be like very high objective value. It has all the possible symmetries in it, but maybe something that is very low symmetrical value, but has some, I don't know, I kind of like that shape, or this weird guy's face, or maybe the gray ones mean that it was a tie between the black and the white, so they're also quite rare. In this agent-based simulation, you're basically presented with this sort of subjective value. If that subjective value is greater than the current price, and you have that I feel like it, which is the propensity to buy, then you would flip the table or buy the Clover. This is sort of the logic that we're using. It's imperfect and it's a simplification, like any simulation always will be. But I think it's still a useful tool, and in a way sort of an obligation to try running things through them, because when you're dealing with real money and real people, you have an obligation to do due diligence. Here's a bonus from that Othello World Championship. All of the players I played, and the listings where you can see I tied for second to last place. So this is Clovers.Network. I mentioned we're live on the Rennekamp network. We'll be launching at August 20th. Mainnet is an event at Full Node during Berlin Blockchain Week. You might have thought about the idea of like registering a Clover on testnet versus the mainnet, and how that presents problems with, I guess, front running, or somebody would be able to re-register all the same ones. And so any of the Clovers which are registered on testnet will be carried over to mainnet. So you can basically mine for free at this point and move over that state when we go to mainnet. We're an open source project. We're on GitHub. All of this work with cadCAD simulation stuff is on GitHub as well. You can email us at hello@Clovers.Network. Open questions. We still don't know how many symmetrical Clovers exist. We don't know how many normal Clovers exist, but there is some sort of upper bound that you'd be able to make based on an 8x8 grid. How many types of symmetry exist, how many redundant types can be removed, and things like that. I've done some sort of napkin math on it, and I don't trust myself. So if that's an interesting question to you, I would love to talk to you about it. The decay rate of mining. So I mentioned earlier I did some sort of mass mining and sort of got some idea of 10,000 hashes equals 1 Clover. I did see that number decreased over time, but I would love to know how it decreases, because we're dealing with a finite number of these things. So these estimates of how rare they are, they could be going up. This is sort of a system which is closed and could be much smaller than we think. Should the reward be a function of time? This is something I've sort of struggled with and thought about a lot, that it wouldn't be so difficult to sort of take when was the last Clover registered, or when was the last 5 Clovers registered, and make the reward some function of that. It might sort of put the brakes on this sort of runaway payout to the miners. What should be the ratio of Clover coin inflation to deflation? I mentioned that like 10x earlier. This is very much an arbitrary number, something that should be looked into deeper. And also the idea that it's a Clover, does token need to accrue value to be useful? So you saw this worst case scenario starting point, in which basically the value of the token is very close to 0. It's just above the cost it takes to mine it. That's the only thing you can do with it. So it's not a very good investment vehicle, it seems. Is that the only use for a token? It seems like so many projects are just trying to sort of pile things onto their token to make it valuable for their investors. But what does a token look like that should be spent immediately, should be useful? Should it stay low? Like what is a token that does that look like? Should it accrue value, or is that damaging to the project? Topics for further discussion I wanted to open up is how to prevent front running. So we've got 3 different solutions that I would love to go into if anybody feels like it. How to save gas, because when dealing with Ethereum, that's always a big pain in the ass. And we've come up with some cool techniques for that if you're interested. And what happens if an NFT is owned by the contract of an ERC20 token. This is the refungible token topic we talked about earlier. So I don't know if anybody's interested in those topics in general, wanted to bring them up. Those are just suggestions and open questions I have myself. So I guess first, thank you for coming. That's officially the end, but maybe we can open it up to have more open discussions. Is this how the open discussions take place now? I have to still stand up here? Okay, great.
I just have a random thought. Do you actually think it's true that if the same user saw the same pattern twice, they would value it the same way the second time?
It's not that they will value it the exact same way, but their value system should still be like kind of locked in to their original. Like they will have a variation on it, and that's what the standard deviation will allow. But the seed for that randomness should be consistent from user Clover partner, or was our thinking at least. So I agree that I don't think they will have the exact same, and probably if you really want to get nuanced, people change. People have life-changing events all the time. But yeah, with any simulation stuff, you have to try to figure out where to draw those lines, and that's always difficult.
To what extent have you been able to take real-world data, for example, to define the policies?
So the hash rate is a real-world data, and the rate at which the symmetries are found. I was mentioning the rotational ones versus the perpendicular and diagonal. Those are the real-world data. It's very difficult to try to use the other economics of the testnet because it's obviously free money, and free money is nothing like expensive money. So we were wary about using any of the other data. I don't know, do you have suggestions for other real-world data?
This could be a good example of what cadCAD was asking for. For example, if, I mean, that would be rather a test than a test arrangement. But if it's really the case that people rate or value the same clover when they see the second time, this would be one, and the second, also the information around it, because whenever you have information on how others value a clover, you might change your mind, you know? So is it a good investment? Or does it make sense?
I think we tried to bulldoze over that nuance with the je ne sais quoi feature, which is like any possible quality of, I don't know what else is going on or why you think it's great, but there's other reasons probably out there.
Have you considered applying this into a deep learning process?
Which project?
So you've got the data and you've got the tagging essentially signifying whether it's valuable or not. Was it?
I mean, these are simulated data, though.
Yeah.
Okay.
But to predict whether a generated clover would be considered valuable or not based on whatever that pattern is, that based on prior.
You mean like after it's gone and we have real data to go off of?
Yeah.
That would be amazing. Yeah. I mean, at that point, we're kind of the fish is cooked, though. You know, like if the point of this is try to inform it before it's live, we aren't able to use that kind of data. But no, I mean, there's a whole treasure trove of data on the blockchain in general of sort of user habits or spending value that would be great to apply to machine learning and get insights. Yeah. I would love to see that also impaired with simulations like the original block science diagram had, which is that you really should put it out in the wild, but you should also be able to edit it and update. And we've treated the project the same way. All of the contracts are upgradable. They're currently upgradable by a single owner contract address, but I would be very happy to put that into a DAO if there was ever enough of a user base or interest to sort of secure that sort of element of trust, which would allow, progressive updates and things like that. Like maybe you decide to remove rewards altogether or lower the minor rewards because you've gotten your 97,000 clovers as the starting point for your sort of like bedrock of data to move out from or something like that. So yeah, I would be very interested in seeing similar things like that happen.
To just comment on top of what you just said, I think in terms of subjective values, you can actually like influence a lot on it, right? Like for example, standard deviation, if you would, I don't know, have like a Clover universe or something like that, and then I can see what's going on around me. Because now I think I think it looks really cool, and I really want to play it. But then somehow it's sort of, it lacks a little bit of context for me to to come back many times, right? I probably gonna play like a couple of days, and then I don't like, yeah. But I mean, if there's like some competition going on or whatever around it, maybe it's.
Yeah, I mean, I think that's the dream of any like game designer is to create like enough of a fertile ground for like emergent behaviors and their own sort of sub games to go on or tensions or drama to take place, you know. And I think that's probably a challenge with any game is how do you find that mixture of this is what you're allowed to do this thing versus open the space up and allow for other things. So that was actually, I mentioned starting at only caring about these symmetrical ones, and then I found that the most interesting part were these asymmetrical ones. Sort of like, oh wow, there's like a weird subcategory of all of these ones that look like Santa Claus, or there was a bunch of Donald Trump looking ones. And it was like, oh yeah, this is great. Let's put these in sort of albums and categories, and like this becomes like a place to have sort of social reference. And then the idea that any of these things which can be sort of like passive gaming, could also be transferable to other contexts is what got me kind of excited in the Ethereum context. That like, sure, like I made this joke once with a friend, but now I can use this thing as my NFT profile inside of some other context with NFTs, or it shows up inside my wallet when I'm doing something completely different or something like that.
Yeah, I think some fun idea is that some of the clover could also resemble the like the alphabet, right?
Yeah.
And then maybe you have kind of like the gallery for the user profile, and I can just put this whatever words. It would be so funny.
It's already started.
It's already started.
Yeah. There's I don't know, maybe 5 or 6 like alphabet letter numbers that have popped up, but it's very much something I'd like to see happen as the rest of them found. Yeah. And so this social element I feel is more and more something that should be emphasized in the project, of the profiles, the comments, that being able to make albums or groups of them and display them in these sorts of contexts that are emergent, from the way people might actually want to use it, or the things that you didn't expect to find out of it.
Just one question: have you, if just to have a reference point, if you would take the 10,000 and if you would just put them into cloud resources and run the algorithm to discover clovers on them, do you know the number?
I think it would be comparable, if not better, but I think you lose a lot of value in having the context or a community or the publicity or the stage of all of it taking place.
And it's an art piece in and of itself, the whole project. So I was just interested to know.
No, totally. I've thought about that too. Like, could I do something better? But yeah, I mean, I think it's the right way to spend the remainder of it.
Is the decision to carry over mine clovers from the testnet to the mainnet a decision to seed kind of the ecosystem with users, or why did you take it?
Partly, but also because of the front-running aspect. There's nothing to prevent somebody from just raking through the testnet and rebuilding them on the mainnet. And so in order to sort of prevent that activity, which is rather hanger-on, whatever that term is, and also to sort of encourage people to check it out again once it's on mainnet. Like, oh, I think I did look at that a year ago. Maybe I have some clovers. You go on and you're like, oh, I have clovers. So twofold.
I would love to hear more about the simulation process, what we talked about beforehand. So what are the current challenges with running such simulations?
Sure. So the network graph is pretty large, and it grows large quickly. And so the first thing we ran into is with cadCAD, every aspect of state is saved at every step and at every sub-step. So every sub-step is those groups of policies and state update functions. So you might have one step, but there were 5 subsets in that. And if your entire network graph consists of whatever it was, 100,000 clovers and however many users or something like that, to have all of them saved in state for every single step is massive. And so we ended up starting to use Pickle, Python data format for saving arbitrary data. So at the beginning of every state update, we read the network graph from disk, and at the end of every state update, we write it to disk and we delete it from memory so that it's not stored inside of the cadCAD simulation software. And so that was able to sort of alleviate our load a lot, but you lose a lot of data. Like, you don't know exactly what each player was doing at every step. So if you want to sort of model their current bankroll or something like that, you don't have as much access to that information, but it's a trade-off in the simulations. So I mentioned that we mostly focused on the reward mechanism, but there's a lot of pieces that sort of need to be examined. The repost amount. I'd like to sort of use a variety of variables for the player growth rate or decay rate. So assuming like much lower, much higher, like how would that affect it? Also, if I mentioned this time as a reward function, element in the reward function, what would that look like, and how would that affect the token price and the activity for miners? If a miner was working all the time, they would just be diminishing returns, so maybe they would only come every so often. Would that be an overall boon for the ecosystem? Would that be a drain on the number of clovers produced? It's also hard to say like what is more valuable, a valuable token or a bunch of new clovers as raw material. And I don't really know how to simulate or test that question.
Is the primary incentive to generate clovers or to opinionate on the clovers
The primary incentive, what do you mean?
for playing the game? For this game specifically?
So I guess that would be dependent on the user. The player would be to opinionate, and the miner would be to strictly hand to mouth. I constantly wrestle with the idea of the miner at all, whether they're too much of a drain on the whole ecosystem, if the real value is in player interactions and sort of interesting player interactions, if the miner is sort of a freeloader, or if the miner is doing a beneficial aspect, which is producing raw material. And I don't really know how to answer that question either.
Yeah, I was just thinking, trying to imagine parallels in other examples like the Human Genome Project, where there obviously was huge collaboration to mine the genome, and whether that may have been in some way improved by having an incentive gain on top of it or whatever. And there's those kinds of, that problem space of processing large amounts of data and opinionating on it. And, yeah.
I think there is a gene folding blockchain project that has a reward for it. I'm not sure what the token economics of it is though, like where the value to the token comes from, or if they like get big government grants to buy back the token or something like that to raise the value. I'm not sure at all.
Because I think it strikes me that like the simulation that you've done here could be usefully applied, or lessons
absolutely.
Those.
And I think that's what block science is really betting on, is that if they create generalizable software, it can be used in so many different contexts and useful in all the different ways it can be.
I'm not sure I understood you right, but you ran the simulation on symmetrical clovers only, right?
Yeah.
Because I'm wondering, kind of, that is your kind of ambition or inspiration as the game designer, but as a user, I would probably be more interested in the asymmetrical ones. What if, in terms of volume, actually, asymmetrical ones are taking way more than the symmetrical ones? Because you said like every 10,000 or something, I find a symmetrical one, right?
Yeah.
So what does that do to your simulation and the bonding curve, like changing in value?
If anything, it should improve it, because all of the times that somebody keeps it, that's a token sink, where the value of the tokens increase because they had to get burned. And so all of these are sort of, again, like I'm trying to take the most pessimistic view on the whole system as possible. And anything above that would be a win. So every clover which is mined that's not symmetrical is a benefit to the entire ecosystem and would raise the value of all the other tokens in existence. And so rather than trying to just sort of walk down too optimistic of a simulation path of a best case scenario, which would definitely include a lot of asymmetrical activity, and maybe it actually is a more honest portrayal of how people would use it, I just wanted to sort of safeguard against the worst case scenario, which is the way I hope people don't use it, which is, yeah, only caring about the symmetrical and only being miners, basically, or being mostly miners.
Just a random idea of how to maybe increase the appeal of this, and with the asymmetrical, what if I could like post a like headhunting fee, and I say I want this clover because it represents like maybe the day I met my girlfriend or something, and I want to gift it to her. It has an imaginable value to me, and I just have to formalize this target function and just put it on a hit list. And if the miner finds something and it's on the hit list, I have like a buy order, an automatic buy order, and the miner could buy it for me, and it would create more incentive to mine.
I like it. I like it. We've talked about similar things, but I mean, I would definitely love to see it. I'm not sure how easy it is to find arbitrary things are. It's like the space is so massive, and it's like if I could get any data that said it was at all likely, I would be much more inclined to make that like a primary feature. I would definitely add it probably deprioritize it to just like getting the basic functions working. But it's something we've definitely talked about because it's a really exciting idea. Yeah, this like sort of bounty hunt or something like that. But yeah, I'm just afraid that it's very unlikely in terms of the massive game tree that you're going to be able to hit this specific one rather than this like very broad category of ones or something like that. I wonder though, like you could probably make something in between, sort of define your own categories or something like that, where it's not necessarily symmetrical, but it fulfills X, Y, or Z, and maybe you have it narrowed down all the way to every single tile is accounted for your extremely specific
some
one.
Ambiguity and it's set and there's some
I mean, even
tolerance.
less automated, you could have sort of bounties for categories. Like I want one that looks like a yin yang, but you know, bring it to me and I'll tell you if it fulfills that qualification or something like that. And they can always provide, you know, the public key version of it without exposing the private key version of it, so you could still sort of.
Oh, then and it would increase the value of spending human attention in the garden, because this is maybe hard to formalize in computer code, but
True.
what you said, finding in cloud noise, this is something maybe just a human can do.
Totally.
Cool.
Yeah, I mean anything that sort of supports like human-centric mining, I'm like very much a fan of, and then it really does lead very quickly to proof of humanity, CAPTCHA. You know what I mean? Which is something that's still like, well, maybe never will be solved because you can always find somebody who's willing to be a human for a price.
I just noticed that you were talking about, okay, I don't know the exact objective. So is it the value of the token itself, or is it activity? Is it the number of active participants? And I think especially in the beginning, it's rather on whatever is avoiding the worst case, and then learning about the objectives that seem to evolve in this overall game.
Yeah. It was the worst case that really made me ask that question too. Like, wait, what is my ultimate goal in this? Like, is it actually to produce as many of these clovers as possible? Like, is it the original goal, which is just give myself raw material selfishly? Or is it, I mean, it's kind of shifted at this point to be like engaging, to have an actual community who cares about interacting with it and providing, if it's going to be value through the token that is required to make that engage into a community, or if it's sort of the comeback appeal of some social layer, or if it's sub games or something like that. Like, that is what I would like to emphasize. I mean, it's also why the token model has burns instead of payouts to my pocket or something like that. It's like every action in it is meant to sort of refloat the ecosystem for the players. So it's not like a way to make money, and it's not necessarily an investment vehicle for anybody either. It's meant to be, and that's what sort of brought up this question of like, what if it is a token value of 0? Like, what if the token value just bounces right above 0 often enough to make people interact with it at like a baseline, but like, this is not meant to be an investment vehicle. It's not meant to make money for you. Like, that's like, sounds like a very exciting use case of a token actually that often you don't come across in most projects. It's all about making the token as valuable as possible, making money in returns. And I kind of like the idea that the token is a vehicle, but not one that's supposed to go up.
And still, it's interesting also what the every single transaction or interaction would do to the token value. I think to see this personal impact on the total system would be also interesting.
Yeah, this was in some of the simulation stuffs, but actually I think what I'd rather model now, I was thinking about it on the way over here, is the curve. So this adjustable bonding curve, you can think of it like a graph where you have mx plus b or something like that. And often this m is very much like the focal point. At least when you use the Bancor formula, you kind of decide what the polynomial is on the x. So is it going to be x to 1, or is it going to be x squared? Is it going to be x3? And then that's tweaked with the slope, with the m. And typically when you use Bancor 1, you solidify that squared or whatever, but that m can be very much adjusted by changing the amount of collateral versus number of tokens in circulation. So I'd love to see, and I'll probably do this as soon as I get home, what does the m look like on these scenarios? You know, like, okay, the m starts out really, really, really high at the beginning because you have a really high value token, and it eventually goes really, really low, and then it comes back up again. Like, how much variation do you have on the rate of change on each of these curves? Because that's constantly changed through adjustable bonding curves. Yep. Anybody?
Final-
We got one.
No, no.
Oh, that's a volunteer.
I have the final one. You go ahead.
Okay.
Will there be a Telegram group for mainnet launch?
Oh, God, I hope so. Hopefully it'll be a completely community-run one. Can't wait for that. I'll make a sticker pack. I will make a sticker pack. Maybe I can automate. Can you automate stickers? Every time like a Clover's mined and new stickers? I could look into this. Does that mean we have your final question?
Yeah, it's up to you. Nobody else? Okay, my question would be, what would be your setup to go ahead? So we have, so tweaks in the game itself, capability of simulation today, and optimize it, and then how to collect or how to use and employ real-life data. What would be your let's say focus, or how would you combine those three, or is there even more to consider in your setup on improving?
Like as a run-up to launch or ongoing?
For example, or over time. So how to use those tools to make it better and better.
I guess I'd want to follow their suggestion, which is sort of continue in that 8, get some assumptions, model it, make tweaks, and then launch, and then from those findings, adjust as well. That process gets a little more complicated because I'd want to have community feedback if there was a community at that point. Maybe it's also easier to be a benevolent dictator to begin with, to sort of rapidly change things, but I would want to distribute power if power came. And yeah, make the decisions about parameters and continue running the simulations, which would become much more accurate probably once you have real data from real life interactions with it. Feed that back in, see what you can see, check your projections, adjust accordingly. But I'd also really like to focus on the UX and the user interaction of it, because if the focus is the user, it should be enjoyable to use. It should be easy to use. We have some ideas about how to get rid of gas completely for new users. Combination of meta transactions and an oracle who's willing to take a cut of symmetrical ones. And also sort of bringing back this idea of proof of work as Sybil resistance. Sort of like offering different features to somebody who can provide a symmetrical clover. They didn't register it, they have it off chain, but if they provide it, this is the same thing as hash cash. It's a way of sort of carrying around value and using it for arbitrary things, which could be useful and sort of if we're going to be subsidizing users' gas at points or something like that. There's a lot of interesting configurations in there. Yeah, so sort of supporting the user story. We use Portis right now as a fallback wallet. So if you show up and you don't have MetaMask or something like that, you can use a traditional email password sign-in and things like that. There's a few different projects working with that right now that are all doing really great jobs, so trying to support that would be a big focus as well.
I was wondering, have you ever thought about using like large image data sets? Because you could find some of these patterns, particularly like if you wanted some sort of like binary option or kind of appearance option. Like I'm thinking like at different scales, like this is me thinking out loud, like Google Earth images or something at different scales could match some of these patterns and certain parameters in a way, and could be kind of like mined endlessly in a certain way. Like it would be very computationally different.
Which direction though? You mean like Rob Meyer's hash face? Or like using machine learning to say, I'm only going to like clovers that kind of look like cats, according to this machine learning algorithm?
I mean, I think what I'm thinking is that it could be like actually even along similar kind of aesthetic or kind of binary lines where there's a set grid and like certain like signal to noise ratios that are similar and could be symmetric or otherwise, and it depends on which scale you're using. But it could go also either way, where you set just any parameters that you have to match. And there is like in a certain way, I would say endless enough kind of satellite imagery at different depths and scales that could serve a similar function. Of course, it wouldn't necessarily, computationally be very different, but that also might be an interesting way to like use a certain image data set to inform it.
Totally. I mean, this always comes down to what is the verification process going to be like, and almost none of that's going to be possible on Ethereum unless you use some sort of optimistic verification system. probably a lot more interesting use cases in that area would be possible through application-specific blockchains, where you have the sort of computational ability to whatever is necessary to verify whether or not this is. I mean, it makes me think of, weren't they using humans to sort of search through satellite images of Mars, something like that, to find like anomalies or interesting things that NASA cared about? And they sort of just like opened up this massive sort of Google Earth data set to the public, and all sorts of people found really very, very interesting things that NASA ended up using in their research. Or maybe it was actually on Earth, or there was also like finding that airplane that crashed was a sort of like crowdsource system. But if you're going to build it into an economic system, you have to have like a pretty strict verification system for that rewards, or you just get rid of rewards, which is also an option sometimes. Cool. Thanks for coming, everybody.
I think simulations and such kind of insights will be a topic in many more token engineering meetups. I think it was now the first time we took a look to simulation results. And yeah, you're invited to join more token engineering meetups, and we'll get into those tools we have who are now evolving and how to use them to make token and economic models better and better. So thank you for tonight. It's really hot here. And hopefully see you soon. Thank you, Billy.
Thank you.